I don't think we'll be working on the other side of that worksheet because I think we all get the idea. So I just want to go over some really, really crucial things. Now, first of all, a number of you requested learning in the dark. So we are going to try that. I thought it would make you more sleepy, but it's cold anyway, so I don't think we are very sleepy. Okay, so I want to stress something because based on what I've seen in office hours, there's still some doubt over what to focus on, and so let me try to and show you what is key, really, really key in this situation. You only at this stage have to keep track of three numbers, okay? So listen carefully. There's always, and all these are proportions, okay? Not looking at that number that floats on top yet, right? The numbers that the proportion, right now it's all proportions. We are going to move on to a mean later, not now. For now, you can just fix your mind on it's all proportions right now. All these are proportions. So the blue one is the center proportion. It's the status quo hypothesized value that you simulate at. That's the one that you assume your friend is guessing, or people are guessing on the test and things like that. What would be the long run proportion? That's the blue number. The red is so important, that's why it's red. This one is the observed proportion. What did your friend actually get? What did you get on the test? Something like that. Then there's this mysterious number that floats on top here. That's the fraction of cases in the simulation that are more extreme than what you saw. Just three numbers to keep straight. I know there are three numbers. They are confusing because they are all proportions. They are all fractions between 0 and 1. Yes. Yes. That part is hard. But three things. Where's the center? What did you see? And what's the fraction of cases? Because some of you are saying, oh, this number is this number floating on top. No, it's not. No, it's not. This number is here for a reason. It's floating on top because it's the fraction of cases that are as or more extreme than what you saw. Right? So if you want to focus on something, make sure you understand this picture and which number corresponds to what. So that's very, very, very important actually. All right. Not everyone is confused about this. I'm just pointing out what I've seen from the experience I've had with office hours. So, okay. So with that in mind, let's go to our notes and try to finish up some of the slides. I think, yeah. So we stopped at 51. Not 51. For me, it's 51. Okay. So remember that when we try to see whether a dolphin or you taking a true false test, whether the score you get is something that happens often or not when you guess, you simulate. You flip a coin, however many times as you reflect the study. So if you did 16 questions, you flip the coin 16 times. Then you do this and generate this picture. And you've seen these plots so many times by now. What are these? These are plots of what happens when you toss a coin 16 times and the coin is fair, 50-50. Most of the time you get 8 tenths, like that. All right, then what do you do? So in 100 sets of 16, so look at this picture first. The left one has dots. You can actually see some dots here because it's 100 sets, 100 replications. In 100 sets of 16 tosses, how often did you get 15 or more hits? According to this picture, did we ever get 15 or more hits? According to this picture. No, we didn't. I see you all shaking your head. No, that's right. There were no cases like that. Let me ask you, if you simulate enough times, will you get eventually one case happening, something like that? Yes. In 100, it's just not enough. So never in this case. In 1,000 sets, did you get 15 or more? Now use your eye. Of course, you're going to use your eyes. Look at, is there a case at 15? I think I see one. I think there's one. Oh, what? Well, apparently no. Oh, that's a tick mark. Okay. Oh, that's a tick mark. All right, to check. Okay, so okay, never. So therefore, is it likely to see scores like 15 or 16 when you guess? And the answer is Yes or no? Is it likely, therefore, to see a score like as good as 15 out of 16 when you guess? The answer is no. And it's proven by simulation. You can't seem to produce a score like that when you guess. But is it possible, though? The answer is yes. Everything is possible. All right? Do we have evidence that Buzz is not guessing? Would you say, if you were a prosecutor in a case, is this strong evidence that Buzz is not guessing? The answer is yes. This kind of thing is strong evidence that you're not guessing. I mean, getting scores like 15 out of 16 is strong evidence that you're not guessing. You tell people I got 15 out of 16 on true false test. Most people are going to conclude that no, you weren't guessing, you did study, you know what you're doing, right? Okay. Yeah. Okay. So, but have we proven though that Buzz is not guessing? Do you understand the question? Can you prove that Buzz is not guessing? In other words, can Buzz get really lucky and get a score like that and guess? And the answer is yes. So, have you proven that Buzz is not guessing? The answer is no. And this is where statistics can be very dissatisfying. I'll tell you what. Do you know that statistics is not in the business of proving whether a thing is a thing or not? It's all an evidence game. I like to say this from a court case point of view, like criminal trials of murder, for example. Do you know that unless you actually saw the murder take place, do you know that you actually cannot uh, conclusively prove that this person actually did it? You are convicted based on the overwhelming amount of evidence there is against you. And that is why sometimes cases are overturned because new evidence shows up. Unless you were there to witness the crime, you actually cannot prove that person A did thing B. You cannot do that. But it's all an evidence game. And that's exactly what statistics is. It's all evidence, evidence, evidence. How much evidence do you have? And that we have strong evidence that you're not guessing. But we cannot prove conclusively that you're not guessing. All right, this is a very key fact. So don't write in your conclusion, we have proven that Buzz is not guessing. You cannot do that. There is very strong evidence that he doesn't know what to do, but it's all evidence. All right, so consider another phase. Actually, the study was less of, the result was actually not that good. They discovered that the dolphins were kind of cheating, as you said, and could actually see what button was. So they replaced that wooden partition with concrete or something like that. Okay, and then they did the study 28 times now, not 16 times anymore. They tried 28 times. This time, the dolphin got it right only 16 times out of 28. So that's not a very, we all know that's not a very promising result, is it? Isn't it tantamount to you taking a true false test now with 28 questions and only getting how many correct? Yeah, if we take a true false test with 28 questions, how many did you get correct? If you want to draw a parallel with the dolphin, now you get 16. 16. Now you take 28 questions, you get 16 right. Is that an impressive score for a true false test? No, it's not. Why? It's very close to 50%, isn't it? 50% is 14 out of 28. What's the moral of the story? Well, we're trying to show you that this kind of observed statistic is not going to provide you with evidence that you're not guessing. It also doesn't prove that you are guessing or not guessing. You can never prove one way or the other. But it does not provide convincing evidence that you're not guessing. You might very well be guessing. Because you do get scores like this all the time. So how do we quantify the strength of evidence? Okay, forget about the earlier 15 out of 16. That experiment has been proven to be the dolphins who kind of cheating. Because they were fed fish or something to together. So they had incentive to get it right. So I guess they're smart. So doing this gave me a fish, so do it. So they changed the study. Now this is the new score, 16 out of 28. Still two buttons, still true or false test, but now didn't do as well. So if I want to quantify how special, how rarely do I see scores like 16 out of 28 when I guess, what do I need to do? Do I still flip a fair coin? Is the coin still a 50-50 coin? Did the scenario change? Is it still a true-false test? It still is. So you still use a 50-50 coin. But how many times do I toss the coin? 28 times. Why? the study has changed slightly. You now toss the coin 28 times and you generate that same plot like that. Then you go check where's 16. And you will find, even without doing it, do you think 16 happens quite a lot? If you take a true false test with 28 questions and you guess all the time, do you get scores like 16 out of 28 quite a lot? And the answer is yes. Is it special to get scores like 16 out of 28? No, it's not when you guess. It's not special at all. And that's what's going on. So you quantify the strength of evidence in the same way. You consider what scores are typical if you guess. Can you give me some typical scores if you did 28 true false questions? How many correct? Can you give me some proportions that are typical? 15 out of 28? Yes. 14, 16, 13. Okay. Anything close to the middle, close to 50% would be typical. And I think you get the idea. Unusual would be very small or very big. Right? So unusual, see, there's a typo. Although these slides have been used for so many cycles, there's a typo here. Can you correct your slide? Out of 28, not 16. There is a typo, right? How out of 28 tries, unusual would be, well, very good. And I don't know why I didn't write some very bad ones. Very bad would also be unusual. It's hard to get 1 out of 28 on a true false test if you really get. It's also quite hard to do that badly as well. So how can we quantify? You toss a fair coin. Why is the coin still fair? Because there are still two options. It's still two buttons. It's still a true false test. You toss a fair coin, but how many times? 28 times. And then in all these, you record how many heads you get, and you see whether getting 16 out of 28 is rare. All right. Actually, you don't even need to copy this down. You know why? I adopted the exact same slide as what you have for the 15 out of 16 case. Just change some numbers around. It's the same word. You must remember, professors are like students, We don't like to do anything extra either. Right? The whole bunch of copy paste going on, and I even made a typo there. See that 16 should be. All right, but anyway, this part is exactly the same. You toss a coin 28 times, and then you record all the heads that you get on a histogram, and then you check how rarely did you get a score like 16 out of 28. And it's pretty disappointing. It's not a very unlikely thing. All right. Okay. I have produced a picture for what happens when you flip a coin 28 times. 1,000 sets. 1,000, if you don't like the word sets, you can say reps. 1,000 reps of 28 horses, you get this kind of thing. Are we surprised? Most of the time, you see 14 heads. Yes, of course. You made the coin fair. So you should see 14 heads a lot of the time. So do you see why have I put an arrow at 16? Anyone? In fact, we don't use an arrow in the effort. This place will be where what will be situated. What is the thing that's at 16 here? On our applet. What do you see at 16? The red line. Yes. You see the red line, which is here as an arrow. Why? Because 16 was your score on the test now. Are there many cases after 16? Yes. Could you have told me that? Of course you could. So it's not special. Getting 16 correct in 28 true false test questions is not special. How often? Quite often. Now, you can't do this, and don't recommend it you try. If you actually counted, there were about 200 cases like that in 1,000. Look at the bars of after 16. There's quite a few cases like that. Not like what we've been doing where it's like one dot or no dots or something like that. There were at least 200 cases like that. Therefore, is it likely to see a score like 16 out of 28 if you are guessing on a true false test? And the answer is yes, it is. Again, I mean, I know the word likely is a little bit subjective, but based off it happens quite a bit. It does happen. Do we have evidence, therefore, that Buzz is not guessing? No, of course, there's no evidence at all, because he may very well have been guessing. There's no evidence that he's not guessing. But have we proven that Buzz is guessing? The answer is no. You can't prove anything. Either way, you cannot prove someone is smart, and you cannot prove definitively that someone is also not smart or not guessing. There is no way. All it is evidence, and there is no evidence that Buzz is smart. That's it. That's all you can. All right. So we are going to immediately work on something very, very similar. I don't think I even want to do this as something on Scratch. I'll talk to you about this problem. There's another experiment done with a dog now. So Harley's a dog, and they put two bowls in front of the dog. I don't think there's anything in the bowl. If you put food in one, then that's not a real test because the dog will most likely go to the one with the food. So I think it was both empty. But what the experimenter did was, I think he leaned towards one. Maybe he pointed at one or something like that. So the dog has to basically go to the bowl that's pointed at. So they tried this 10 times, and the dog got it right 9 times in 10. All right. So that's a study. Notice 2 bowls in front of dog. Is that parallel to a true false test with how many questions? If you want, okay, we are not looking at bowls, but if you wanted to translate this to a human example, how many questions are we considering on a true false test? 10. And how many did you get correct? 9. That's right. So, do you think getting 9 questions correct out of 10 on a true false test when you guess, do you think it's quite rare? What makes you say it's quite rare? Well, it's very good. Again, let me ask you, in the long run on a true false test when you guess, what is the proportion you should get correct? On any true false test if you guess? Give me a decimal. Don't say 5 out of 10, but say what? What is the long run proportion of answers you get correct on a true false test if you guess? 0.5. Does that change here? Is it whether dolphins or dog or true false test? If it's a true false test, if there's 2 options and you guess, long run 0.5. So how would I see how rarely I would see a score as good as 9 out of 10? You simulate 1,000 reps of how many tosses? The 1,000 reps doesn't change. But how many tosses should each rep have now? Anyone? The number of tosses must reflect the study. Now I'm reflecting the dog study. How many times should I toss the coin? 10. 10 in each rep. So you simulate 1,000 sets of 10 flips. Actually, you can improve what I have on the slide. Should the coin still be fair? Should it be a 50-50 coin still? Yes, good. I like how convinced you are that it's still fair. Isn't this still a true false test? It is. The type of coin that you use must reflect the study that you do. So it's a true false test, then yes. All right. Note that using coin flips assumes that the dog is, and what word do I want? It starts with a G. The fact that you flip a fair coin, actually, this would be a little bit clearer if you put using fair coin flips assumes that the dog is guessing. Not that the dog dogs guessing. So you check how rarely do you get something like, and what's the score of interest? What's the red box? What's the proportion that's in the red box here? 0.9. What's the proportion in the blue box? 0.5. Right. You check how rarely getting something like 9 out of 10 is if the dog is guessing. So the whole purpose of simulating is to see what happens when you guess. Most of the time you get about half right. Sometimes you get a little bit lucky, you get more correct. Sometimes you're unlucky and you get less than half correct. But on the whole, centered around the middle. So you just check, what did you get though? Well, you got 9 out of 10. That's very extreme. Yeah, and things like that. You check how rarely getting something like this if the dog is guessing. So I'm going to ask you now, any group, go fire up the sketch pad. Just give me a screenshot like on Monday of everything from the place where you have to put the three numbers, in the boxes, until you get the thing. Make sure you're in proportion mode with the red line. Tell me how rarely you get something like 9 out of 10 if you guess on a true false test with 10 questions. I mean, you don't have to talk about the dog. How about you? True false test, 10 questions. How rarely do you get 9 correct if you guess? Right? So can one group do that, or maybe two groups? Maybe you get a slight variety of answers. Let's have two groups do this. So just I'm going to call out Scratchpad now, and here's what I want you to do. Okay, so let me. Okay, here we are, and I'm going to call this Harley Phase 1 because there's a Harley Phase 2 as well. So in Phase 1, Harley's score is 9 out of 10. Okay, so can I have two groups? Show me two screenshots. And I want a screenshot that looks like this, okay? I want everything. I want it to be in proportion mode and starting from here to here. Thank you. That was very fast. Thank you. So let's blow this up a little bit. It's very small. Oh, this is excellent. Do you know everything's correct here? Okay, let's point out why. Is the probability of hits 0.5? Yes. This is a true false test. 1,000 that never changes. We always do 1,000 reps. Why is the number of tosses 10? Because that's the study. Now it's 10. Sometimes it's 16, sometimes it's 28, now it's 10. Here's the graph of what you get when you toss a coin 10 times 1,000 times. So most of the time you're around the middle, 0.5. Why is the red line at 0.9, which is correct? Why? It's at 0.9 because that's your observed score. So you see, the 0.9 is here as well. So this number is identical to this number. This number is identical to this number. So I'm going to just introduce one last concept. That's the purple thing. What is the estimated probability of seeing scores like 9 out of 10 or better when you guess? Can someone give me a fraction? Do you see it on the screenshot? Quite small, but I think on your page you should see more clearly. Can someone give me a statement about this? That's right. Now, for some reason, I don't know. Am I, is my eyes deceiving? This is 2,000 simulations. It's not wrong. It's not wrong. It's okay. Typically, we do 1,000, but basically, you see it in about 8 cases in 1,000 simulations. That's the estimated probability. Is this okay? This is the number that sits here, okay? It's not this proportion here. These are observed, centered. This is the fraction of cases that are as or more extreme than what you saw. That's it. It counts how many cases are like that and divides by how many times you simulated, which typically we keep it at 1,000. Maybe we'll have another group. Did anyone do 1,000 and get something different from 8 in 1,000? Is it 9? It's 12. 12. Yeah. Can you paste that, please? That would be good. I want to show that there is some variability, but not at all. You won't get 500 cases in 1,000. That's not going to happen. All of you should be getting things quite close to 8 out of 1,000 cases. Sometimes you get exactly the same as your friend. Sometimes it's slightly different. All right. If you could just paste that, we can just compare the two. That will be good. You can put it here if you want. Oh, oh, that's nice. Okay. Well, one thing yeah, that's see. Do you see why there's 12 cases? You see, one thing about simulating 1,000 dots, you don't see the dots anymore. So people don't know that there are dots here, but actually there are 12 dots that are there. And see this fraction here? See, in no way is this number the same as this, but they're different things. This is the proportion. This is a proportion. This is a fraction of cases as or more extreme than what you thought. I told you three numbers to keep track of. Center, fraction of cases more extreme than what you thought. And that helps it. Now, if you are using a Windows machine, there's this snipping tool that helps, and you can get nice cuts like this. Now, is there a snipping tool on a Mac? Okay, so that's a tip for you. If you use that, you can zoom in on exactly what you want, so you don't have to have extraneous space and all that. Good. Are we clear on this one? I hope the class is on track with this one. So now let me go to the more disappointing Harley phase 2, which is, where's Harley phase 2? Yes, okay. So actually, again, the dog, they want, okay, this is not as disappointing as the dolphin, but they wondered whether the dog was trying to please the human by going to the right direction. So they replaced the human pointing at the pole with a mechanical arm. Okay. And now the dog got it right 6 times out of 10. So maybe there was a human thing. Dogs like to please their humans. Right? This is how dogs are. Cats, something else, right? But dog, yeah, we'll talk more about that later, right? So I like dogs in theory. I like what they stand for, but I can't. I
Do you have any pets?
No, I don't. Looking after number one is enough work already. So
Oh,
but I like what dogs. Well, yeah, I like their characteristic. All right. Some people don't. They think that dogs are too. They actually find the desire to please off-putting. They actually find that cats have a more individualistic streak. They're nastier and all that kind of thing. So, but okay. Anyway, I have lived in houses with both dogs and cats, not together. Ugh. I I once stayed with a friend who was cat sitting. He's still a friend, yeah. But the cat, I don't know what happened to it. But it was so. I tried to like not interact with the cat, hoping that the cat would get the message and leave me alone. It did not. Right? So it worked the other way. All right. So it's like I'm gonna make him love me. Right? They can okay. So anyway, uh, okay, but anyway, so it just does seem to indicate that the dog was trying to please the human because when you replace it with a mechanical arm, didn't do as well. 6 out of 10. But what's the purpose of this? I'm just trying to tell you, if you got a score like 6 out of 10 on a true false test of 10 questions, it does that happen quite a bit? And the answer is yes. Can you see why? Even without re-simulating, if you went back to the scratch pad, you don't have to re-simulate. Do you know why? Is it still the same study with 10 questions? But what would happen? This red line would have to shift to where? To 0.6. Now, even without doing it, I'm not even going to ask you to repaste. But you could. If you change this to 0.6 now, you could do another screenshot. If you want to do that, you can, but you don't have to. But you can imagine, if you change this to zero point 0.6 because that's your new score now, this line would now be here. And are there more cases after 0.6? Yes. So it's a score like 0.6 special on a true false test you took a question. Can you guess? No. It happens a lot. And that's the idea. So you would simulate the same way. And again, 1,000 sets of 10 flips is still 10 because for some reason with the mechanical arm, I still did 10 tries. If I had done 15 tries, then you flip the coin 15 times. Note that using coin flips assumes that the dog is guessing. See? You always start from the guessing hypothesis. Status quo is always guessing. People don't know how to do anything, they're just guessing, things like that. And you check how rarely getting something like 6 out of 10 is if the dog is guessing. Again, you don't have to copy this slide because it is identical to the previous one, just change one number. Now it's not so special. 6 out of 10 is a typical score when you guess on a true false test. So I think, shall I? Yeah, I think we will do some definitions that I want you, because we have done so much preliminary work. I think you're ready now to do your first Moodle group work. Okay, so the Moodle group work It's on Moodle. It's not on paper, but you work with your group. But everyone needs to input their answers, okay? Everyone needs to input their answers. You cannot have one person in the group input because Moodle doesn't know who your group is. So everyone needs to put their answers in. So I tell you what, can you do that now? Group work 1 should be open. Do you see it?
Yes.
Okay. So I give you 10 minutes because maybe it doesn't take that long. Everything there is doable at this point. There's nothing there. You need the applet though. So make sure you have the applet open. You're going to need the applet to complete the group work. All right. So you need to have well, you need to be looking at this. You need to have this applet on so that you can evaluate how likely you are to see something. All right. So give it a try. Yeah, it's under the group work section, which you GW1. That's right.
Okay, 12 out of 20. 60 out of 20.
Yeah.
Both ones are just gonna see what is the long run proportion of answers. That's just 0.5. Sure.
Oh yeah, how many decimal points? 4.
I don't think so. I think we're not less than.
If you're guessing in the long run, you're going to get 0.5.
So like you should do this. Data. What was friend
Yeah.
Yeah. So as a decimal. Is it that one? It must be. It's the same proportion of repetition. But these 0.
Now, I know I have not introduced these symbols. Just ignore this part, okay? Ignore the H thing. Just look at which symbol represents the fact that you say you're guessing it. Things like that. Yes. Oh, yes. Always do 1,000 reps. That's yes.
So it'd be yes, it's not highly unlikely. So to make it likely, it's kind of worded weird.
Oh, wait.
It's not unlikely, so it's
Yeah.
why.
I know.
Yes,
I know.
highly
It's kind of it's just worded. It's just worded. Did you say that there's strong friend actually understands
No, it's not. There's, I mean, I don't feel like they're really bad. They're getting slow.
Yeah, I don't. Are you serious?
So no.
There's not
strong except they're good.
I think it's yeah. There's not. It's 25. Okay, now 4 and 2.
So 16, yes, 10 out of 20 always have, but 12 is that's
Okay, and then so it's 0.0110. Yes. Okay. Is it highly unlikely to see scores?
I think it's 16 out of 20.
Yes.
No, it's not likely.
Is it highly unlikely this is scores? Not likely.
Yeah. Would you say there's strong evidence if they're not guessing close?
Wait, what did you put for number 10?
10? I put no.
I guess not.
Like if someone's
Is it
guessing,
possible?
oh,
Yeah, it's possible. So yeah, I was gonna say, yeah. Would you say there's strong evidence?
They're all wet. They're all blended into one question.
I feel like this is a
Yeah, we can definitely.
Which one?
Friend two really does understand.
But we can't prove anything, so it's false.
they would need to do
We literally said we can't, literally, we literally said stats can't prove anything, so it has to be.
I like how you think. Hearing your mouth it out, this is really good. It can't prove anything.
Don't trust it.
But it's an evidence game. Is there evidence? The answer is yes. There's evidence, but you can't
But it
prove.
doesn't prove
It doesn't prove. We can never prove. There is no evidence strong enough to ever prove.
So 11, why? Strong evidence of intuition, so that could be yes, because
There's strong evidence.
There's strong evidence, but it doesn't.
Because can you get 16 out of 20 when you guess? You can. And it is because of the possibility that you can get such a good score, you can never prove the 16.
I think we lost that.
I think you're done. That's it.
Okay.
So don't worry about the part about estimate the probability. Put your answer in. I have built in a tolerance. Not everyone's going to get the same answer. One table will get something, but they should be close.
It's pi used as
Yeah.
forever.
I need to like go back. And
It's used for like
It wasn't too bad. This is representing like
I don't know, like, I keep putting in the numbers, and it doesn't tell me.
I know.
I feel like I'm doing it right, but I'm just messing up the answer.
I feel like our test, like, takes the reading greater than the blue line, which is like what you would expect, even if it's higher than.
I did some. Opened up a new tab.
Okay, that's all rated.
Because it doesn't grade it.
And how much zero is not graded?
What's not graded?
Somewhere zero?
No, you have to go to grades.
Yeah, but it doesn't like, but it'll say it, but it won't calculate it.
Oh, mine was.
Wait, what's
Is homework zero like a part of your grade,
Oh,
or is it
it says-
optional?
well,
It says.
Like, will it not
okay.
count?
So Moodle doesn't, and so it just puts all the grades in, but in the end, it just
won't.
converted to a bonus. It's a bonus point out of those English is 1 point.
Okay,
But that's on Moodle.
okay.
Moodle doesn't.
Moodle's stupid.
No, it's not. It's just that there are ways to make Moodle know, but it's pretty complicated. Do you all like Moodle?
No.
Well, I like it more.
In high school, I used Canvas,
No.
which is a little similar to Moodle, but a lot easier to
Mhm.
navigate. I felt like.
I just wish all professors would use one thing because some.
Don't they?
No,
I have
a
a
lot
professor
like
who uses
teachers.
Canvas. One of my professors uses Canvas, and then last semester, one of my FYS professor didn't use Moodle at all or anything.
Yeah,
Just had to
like
submit
I,
stuff through email.
no, I have a lot of teachers that they won't use Moodle at all, and you have to like go through like 5 different documents to find the homework, sketch.
Yeah, you just send him through email.
I have not.
Yeah. And then he emailed me back a score.
Also, that means my class is actually quite
It's good. So I couldn't see my grade except for at the midterm and at the end.
well, there are really some professors who are very old school.
Well, I didn't think, I don't know, they just don't have, I don't think they know to use Moodle, so they just don't try to learn.
Moodle is so clunky because it's meant to be very simple.
Yeah.
But it is hugely clunky. It's like, if you don't click the edit button, then you scroll to the bottom. It's a
Yeah.
pain. It really is a pain, but no, it's
So you have it easy to follow.
okay. That's good. Alright. Okay. So I think most of you should be done. Wasn't that hard, right? Because I prepped you so much already. Why did I fix finish? Does anyone in this class have Finnish heritage? I always ask every class. I'll tell you why. Finnish heritage? Like, does anyone have ancestors who came from Finland here? Okay, no one. I've had classes where there's one or two. You kind of know if your last name ends with an NEN or LLA or things like that. I mean, like Dutch names, there's the Van and the SMA, you know. If your last name ends with an N, like Hakkinen, Lakkinen, this kind of name, it tends to be Finnish. Okay, why am I saying? Because Finnish is an extremely difficult language to learn if you're coming from English. There are very few cognates. There's almost no connection at all. Right? The words are like crazy different. Right? Like red, the color red is punainen in Finnish. All right.
That makes no sense.
There's no connection at all. And you should try something strange. I've done it. You go YouTube and look for Friends subtitles Finnish. It'll blow your mind. Because you hear the familiar things in English, but you look at the words that are at the bottom, it makes no sense at all. Right? And not only are they distant, the grammar is so hard because you can conjugate. I don't know whether that word means anything to you. You've done any language study. You can conjugate verbs in so many ways. So let me just show you. All right. Ah, yes. Here are all the forms of the word red. Yeah. There are 15 cases in Finnish. I think English has like 2. Cases means
Red and road.
where's the subject? Yeah, so you have red, redder, reddest, redden, maybe. Okay, but look at this one. Okay, I don't even know if Finnish people even know every single one. All right. But anyway, so okay, why is this interesting? Because during the pandemic, I was bored out of my mind. So I took it as a challenge to learn Finnish. I wanted to keep my mind active, and what better way than to pick something so distant that your mind is forced to form new neural pathways, and it worked. Yeah? And I did. Okay, I kind of regretted because Duolingo I've already finished the course. I'm now on a 1,000-day streak, and I keep repeating the same things. But the thing is,
You're fluent in
no, I'm not. I'm good at Duolingo Finnish, right? And Duolingo Finnish, unfortunately, is not a very extensive course, so I've kind of exhausted it. But so now I do the daily refresh to keep all the vocabulary straight. But it's if you want a challenge, go do that, right? It's really hard. But that's what I did. So that's why. All right. So okay. So but okay. So where are we? Okay. So now it's time to get some definitions in. Okay. So what's a sample? Well, the sample is the set of everything that you observe. I think this doesn't come as a surprise. Now, please bear in mind, okay? A sample may not be a real thing that you can touch. You can have a sample of free throws, but you can observe your free throws. So the sample is the set of things you observe. The sample size, obviously, is, well, how many things did you observe? All right. And let me ask at this point, what is the international symbol for the sample size? Give me one letter. No, okay. Which one is it? What? I've tried to sneak it in a little bit. Did you know this? What's the and? That's right. And. It's always and I think for number, I think, but it's almost. I don't think there's anyone that does it differently. N is universally sample size. All right. What is a statistic? First of all, let me ask you: is a statistic a number? Yeah. But it's a number that summarizes the sample. I put in parentheses, it's known. Statistics are known. You know that. You saw your sample, you calculated the statistics, so it's known. Can I have someone tell me a sentence that looks very close to this sentence, but change a couple of words? A parameter is it still a number? I thought a parameter is a number.
The population.
That's right. A number that summarizes population and is a parameter known? No, it's not known. Good. So typically, I mean, when I say it's unknown, Okay, I have to put a disclaimer. It's usually unknown because can you find out the population parameter? Yes. If you do a census, if you do a census, and there's some of these things which I find very interesting. The word census, the concept of a census is extremely old. And if you read the history, I think I'm not sure which book exactly. Yeah, King David got into trouble for conducting a census. I'm not sure what book that's in. Is it in 2 Samuel? I don't know. 2 Samuel maybe. But the thing is, he got in trouble because he did a census. And what was a census? He counted every single one. So King David could actually know the proportion of fighting men in Israel. So it's usually unknown. Wow, we've gone very far, haven't we? But basically, a parameter is a usually unknown number that does summarize the population. So what is statistical significance? You've probably heard this word. I'm introducing it now formally. Statistical significance is a result that is unlikely to occur by chance alone. Notice, unlikely, not impossible. So getting scores like 9 out of 10 on a true false test is a statistically significant result because it's unlikely to happen when you get, not impossible, but unlikely. That's a statistically significant result. And these are not very rarely, I'm sure you've heard these terms thrown around, but I'm formally telling you what they are, all right? Okay. I would say this is an important slide. Revisit it from time to time because there are a few, this is some of the jargon that you will, and we will use these terms again. In fact, it's not super hard, but you will get the chance to revise them in a later slide. Just putting it out there now. So okay, remember I told you to ignore those H things in the group work? Well, I'll tell you now what they are. So there's something called the null hypothesis. It's H0. It's just a symbol, right? What is this? The null hypothesis is the just by chance statement about the parameter. So if you paid attention during the group work, we said the null says, the colon means the null says a hypothesis. It is the statement that says you are guessing. You don't know what you're doing, you're guessing. That's why you should have answered, and I hope you did, that the null hypothesis in the Finnish problem was pi is found. That's the guessing hypothesis. That's the you're doing everything by chance hypothesis. All right. The alternative hypothesis is the no. Something is up, you are not guessing. Now we are not talked very much about this. So don't worry too much about it right now. The alternative hypothesis. We are focusing more on the null first. Right? The alternative is the alternative that the null says that you are guessing. The alternative is you're not guessing. You are smart and things like that. All right. What's the null distribution? Now this one's not new, but of course you've not seen this word before. This is that picture of dots that you've seen so many times. That plot has a name. Those dots that you see is the distribution of the statistic when the null hypothesis is true. That is why it's called the null distribution. Remember, when you generate that picture, you assume something is true. You assume that you are guessing. Flip the coin, and here are things you see when you flip a fair coin however many times and things like that. That is actually generated under the assumption that you are guessing. So you see, the null says you're guessing. And so this is called the null distribution. It is the set of dots that you see when you assume that you're guessing. And you assume that the null hypothesis is in play. Okay, like that. So what is the parameter for the Buzz and Doris dataset, the dolphin dataset? Well, the parameter is the long run proportion of attempts that Buzz will get correct. So a bit of revision here. Why are we using pi and not p hat? Because anything that is long run is not known, right? Do you ever know what your true long run free throw rate is? You don't, technically, because you can't finish doing free throws. I know people publish free throw rates, but they're not actually long term. They're not, because you're not done doing free throws. Because you can always do them more. So anything long run is a number but it's not known. So we give a Greek symbol pi. All right. So what are the null and the alternative hypotheses specifically for the dolphin data set? Well, the null says that you're guessing, right? Or the dolphin is guessing. When you guess, aren't you saying pi is half or 0.5? That's right. Whenever you guess on a true false test, what are you actually saying? You're saying that when you guess on true false test, it means in the long run, you get half right. But if you say that you're smart and you're not guessing, then what's your alternative? That your long run proportion correct is more than half or less than half. If I say that you're smart, what are you saying? Your long run proportion of answers you get on a true false test should be greater than half or less than half. Which is it? That's right. So the alternative hypothesis looks like this. I want you to pay close attention to this. Know that the equal sign is always found in the null hypothesis. Now let me ask you a slightly more challenging question, and I'm confident that at least someone will know the answer. Why does statistics always start simulating under this assumption, the null? Why do I not ask you to simulate under the assumption that the alternative is in play? You know what I'm trying to say? Why do we assume the null is true and then we simulate and get those dots and all that? Why do I not assume the alternative is true and simulate? Does anyone know why you can't do that?
Would the alternative be like an outlier?
You're on the right track. What is it about the alternative that actually makes it you can't simulate if you assume that the alternative is true? Why?
Because you don't have evidence for it.
That I think you all kind of know what you want to say. But what I'm saying is, how do you simulate? All right, you repeat. But do you have to tell the computer what type of coin to use? You do use what? Remember, there's something you specify every time you simulate. What's the thing that you specify? You specify how many tosses, yes, how many reps, and there's one more thing that people tend to forget. The probability of heads. Now think along those lines. You have to put in the probability of heads. Is it clear why you cannot simulate under the alternative? What does the alternative say? The probability of heads is greater than half. Are you specifying an actual probability of success? Are you actually specifying what pi is? No, this is
just greater than.
it is a range. It's vague. Therefore, you can't. If you go to the app is going to look back at you like, what do you want? What pi do you want? The alternative is vague. You are smart. Yeah, how smart? It doesn't say. So the only one that is concrete that you can start with is the guessing hypothesis that no, you're guessing. You don't know what you're doing. In the long run, you get half right. That one, the computer is happy because you're saying, okay, let's toss a fair coin. Tossing a fair coin is the guessing hypothesis. That is why all simulation is done assuming the null is true. You cannot. It's not the alternative is wrong. It's unsimulated. You can't simulate under it because you didn't specify what pi is. All you're saying is, it's like saying, I think this person is older than 30 years old. Yeah, how old? You didn't say. Something like that. All right. So these are some important things I want to note. Okay. Here's the biggest thing that I always approach with a lot of fear. Like, what is the p-value? I'm sure you've heard this word before. Well, let me take your fears away. Remember that fraction I've been talking about today, the one that I put that purple colored arrow pointing that fraction that sits on top. Let me show you the sketch pad. The p-value is this. This is the p-value. Not this. This is the observed proportion. This is the centered proportion. This is the p-value. And what is this? How many cases are more extreme than what you saw? That's the p-value. So, in words, it is the probability of getting an observed statistic that is as or more extreme than originally observed if the null is true. It's very long, but it's very important. It's a probability. Now, there are people, and I really hope it's not you, who cannot distinguish between three things: pi, p hat, and p-value. They think they're all the same. They're not the same. I've shown you they are all different. They are all on the screen in three colors. The p-value is that fraction that sits on top. The red box is the observed. The blue box is pi. It's the hypothesized middle. All right. Always go back to that page where I have the color. The blue box is the middle, that's pi. The red box is what you observe. And the fraction that floats on top, that's the p-value. It's the probability. Do you know that when you answered your group work on Moodle just now, you actually gave a p-value? I didn't use the word p-value there. I asked you, tell me the probability of getting a score is good. I was asking you for the p-value. I just didn't introduce the name there. All right. What does a small p-value indicate? A low probability of getting the thing. So therefore, yes, a small p-value indicates evidence against a null. Why? If there is a low probability of getting the thing that you got, that means is there evidence that you're smart? Yes. So it's evidence against the guessing hypothesis. It's support for the smart hypothesis, which is what the alternative is saying. I know this is a bit technical, so go home and revisit these slides as soon as you can. I mean, it's quite unfortunate that this class, the last time I see you is like middle of the week, and then the next time is 5 days. It's not a very good timing, I must say. There's too much of a weekend, but too long. So make sure that these ideas are solidified, okay? I'll say this again. The null hypothesis is the guessing hypothesis. You always simulate under the assumption the null is true. So you get the whole null distribution. Then you check, what did I actually get? It's somewhere way out there. So my p-value is small. It means what? I'm very unlikely to get scores like that when I guess. And that means I have evidence against guessing. I have evidence that I do know what I'm doing, but it's all evidence. So conversely, what will a large p-value indicate? If the probability of getting something like the dog example, getting a score like 6 out of 10, that happens quite a lot. So the likelihood of getting a score like 6 out of 10 when you guess is quite high. That would mean your p-value is high. And that would be, how would you phrase it? No evidence against the null. It is insufficient. You cannot dispute. There is nothing to say against the null. If you tell someone that my true or false test came back with 6 correct out of 10, that's not evidence against guessing. It's plausible that you are guessing. And this is a big word that I want to explain. Plausible. I mean, it's in English and it's used, but less often than possible. It's not the same, okay? Possible and plausible, not the same. Possible, it can something happen. It's an easier concept. Plausible means, is it something reasonable to say? Let me give you an illustration, okay? You leave some food on the table and you have a cat in the house, okay? You come back and the food's gone. Is a plausible explanation the cat ate it? Yes. What's an implausible explanation? Your friend from your neighbor broke into your house, or a dog ate it, and there's no dog around. Okay, those are all yeah. My dog ate my homework, so it's implausible. That's what plausible means. I mean, could it happen that your neighbor broke in and took his dog in and stole the food? Yes, it's possible, but it's not a very plausible explanation. And statistics is all about evaluating the plausibility of something, not whether or not. It's easy to tell what's possible. Everything's possible. It's possible that it may not snow anymore for the rest of the winter. It's possible. It's not very plausible, is it? It's not likely to happen like that. So statistics is all about plausible, not we don't really care what's possible because it's very easy. All right. So that's it. So when I say small and large, don't I need to give you guidelines? I do. Here are your guidelines. Make sure you print this slide out and keep it by you. Right? So that when you do your homework, this is our class benchmark. If you get p-values that are really small, anything under 0.01, we're going to declare as very strong evidence against the null. I mean, it's subjective, but we need to draw the line somewhere. So in class, we standardize. If your p-value is as small as 0.01 or even less, that is considered very unlikely to happen when you guess. And so we say that's very strong. And you can see as the p-value grows, the strength of evidence degrades from very strong evidence against the guessing to strong to moderately strong to well none. So in other words, even when you reach 0.1, getting a score like, that happens about 10% of the time is already considered not very outstanding evidence against guessing, because it does happen. So this is our range of values that we use in the class. So now I'm going to just ask you, what do you think, right? Is there something else at play here? Because so far we have always talked about, well, you get 15 correct out of 16, and that's a pretty good score on a true or false test. So the evidence is strong that you're not guessing. Again, not proving anything. But let me ask you a question. What if I got 150 out of 160 on a true or false test? Now, why am I choosing those numbers?
A lot higher.
So you're okay. So listen carefully again. Getting a score like 15 out of 16 and 150 over 160, are they actually the same score? They actually are the same score, but something in your gut tells you that they can't be treated equally. Numerically, they're the same. Which one is stronger evidence against guessing? The second one. Isn't it harder to get 150 questions correct out of 160 when you guess than getting 15 correct out of 60? So sample size does come into the picture, which is why I want you to think about this in this worksheet. Okay, so just pass that to the tab. Okay. 4, 5, and 4, yeah. Yes.
On the place.
I don't know. I'm just like putting stuff in.
I don't know why,
You take two balls. It's 70. Yeah.
This is probably the one stuff like this.
Yeah.
A sample proportion. 70 out of 100. 70 out of 100. It is 0.07.
No, just 0.7.
Oh, it's
It would. Because you observed it.
So 70 out of 100.
Just write it in the equals or just.
Yeah. Yeah.
Oh.
Both of them. That's what it said. Accessory. Oh, yeah. We just do it again. Yeah.
So when you want to describe the population, what are the words that should come out of your mouth? It is the complete collection of, you can finish. It's the entire collection of
Oh.
I think that's there.
Wait.
Combine it with the complete
So the parameter here is pi. Can you tell me what pi is in words? All right. So go look at the dolphin slide. Oh, no, it's not that one. Okay. That's that.
Apple pie.
No, not that one. Okay. So pi is all the parameter here is pi. You've only learned one parameter, which is pi. Not PIE, okay? So pi, this is a long run proportion. Okay, but please change. Okay, it's not buzz. Can you rephrase that for you? It is a long run proportion, but how do you phrase it?
Wait, no, that's just stuff on the entire cholesterol. What is that?
of all of the.
Yeah. Process.
Yeah.
I think that something like that.
It was like more of a group.
So as usual, I'll give you all a couple more minutes. It's not a lot of things to do, and I would appreciate it if you can start to contribute these things on Moodle. Okay, so let me actually get the text. Okay.
That one.
I think it's I think this one's. Well, wouldn't this one be the normal? Because it's like the other one has to be so far fetched.
Yeah.
Right?
So you just 70 out of 100.
It's more than 50, but
It's rare.
it's not like 90 out of.
It's the big, I don't know, like in the true false.
But 70 out of 100.
It's close.
It's still close enough where it's like, oh, you definitely got 70.
But also too, it's like not 10 questions, it's 100 questions.
Yeah, so
It's like
that-
more. Yeah.
So that indicates they're guessing.
But I think you can use the 100 kind of basis. Like, recognize what you mean.
Don't worry if you are confused, because that's what this is for. I want you to think. All right.
Like, do you think it's more like closer to alternative or no?
I feel it.
Because it's out of 100. If it was out of 10, I'd probably say it's no.
Yeah, but I think
Yeah,
I think that's
getting 70 right when you're guessing.
that's crazy.
I think it's.
Yeah, I mean, and then you can think about the cost, 700.
Yeah, so that's why 7 out of 10 is the normal.
Yeah.
Set H sub.
And then the dot equals 1/2. So it's equals pi. So 7 out of 10, right?
So I realize some of these may make you confused, and that's kind of why I wanted to do it at this stage. All right, not to make you confused, but there are things I want to iron out. So can I have you answer some of these on Scratchpad so I can? Don't change your answers. Whatever you have, I told you it's great my confusion. I want to know at this stage what you know. So don't change your answers. Can I get someone to just type here some answers that you have? If you take a true or false test with 100 questions and get 70 correct, can you give me the symbol, the fraction, and the decimal? These are not trick questions, you know. There's nothing. I'm trying to trick you. It's not. Some of them are very on the nose as well. So you get 70 correct out of 100. What's your score? All right. Anyone at all? We'll try. I want to finish this in 10 minutes. I think we can. So yes, your score is 70 out of 100, which of course is 0.7. Good. And what's the symbol we give for this? Very good. I noticed that the speed at which you answer is increasing, which is good. Right? It's p-hat, it's not pi. This is something you saw. And don't you have the same batch of answers actually? But if you take a true false test with 10 questions and get 7 correct, yes, your score is 7 out of 10, which is of course 0.7 p-hat. But what am I getting at? Somehow in your gut, you know that one score gives more evidence than the other, although they are numerically the same. All right. So describe the population being considered here is the entire is process. It is the entire collection of what? It's a process. Good. And it's a process. It's not physical, obviously. It is the entire collection of attempts on true false questions, something like that, right? Okay, define the population parameter of interest. I'm telling you, it is pi. And when you see pi, you must say the word long run proportion. But long run proportion what? Can you change that word? It's not dolphin anymore. It's the long run proportion that you what? What are we measuring? Right? This is the process population of true or false questions. So it's the long run proportion that what? What are you measuring? A proportion is a number. What is of interest here? Right? Pi is a long run proportion, but of what? Right? Does anyone know the answer to this? I know we have not talked about the definition of the parameter for a while, but you want to give it a try? It is a proportion of, a proportion has to be of something. Of what? It's a process population of attempts on a true false test. So what does pi measure? It's the long run proportion of something to do with the answers. Well, what about the answers, right? It's the long run proportion. Okay, not the AI is wrong, right? It's not of population. It's the long run proportion of yes, correct. Right? It's the long run proportion of correct answers on a TF test. Is that okay? What else could you be interested in? The long run proportion of snowy day. We're not even talking about that. The only proportion here that you're concerned about is, what's the fraction you got correct in the long run? Good. So now comes something. Write down the null hypothesis. I know that I've introduced it only very recently. Anyone want to try? The null is H0 says pi what equals what? Just give me a decimal. The null says if you are guessing that in the long run, your long run proportion correct will be 0.5. Good. Now, can someone tell me what does the alternative look like if you are not guessing and are smart? Can you change one thing? The alternative doesn't say pi is 0.5. The alternative is vague. That's right. If you are not guessing, don't you expect your long run fraction of getting correct to be more than 0.5? So just change that to a okay. I don't know whether anyone in this class is always confusing this sign with the other signs. I just thought of something to help you. I am greater than you, so I'm poking you. If that helps. I don't know. Okay. Now, what is the? Well, this is really good. I didn't even have to go to the picture. I will now, though. What is the distance from your score to the hypothesized middle score? What am I asking for? Where's my famous picture? Here it is. I'm looking for the distance between the red box and the blue box. Hypothesized, actual, observed. And it is 0.2. Good. 0.7 to 0.5 is 0.2, right? The distance from 0.7 to 0.5 is 0.2. Notice something? Are both the distances the same? Whether your score is 70 out of 100 or 7 out of 10? It is the same. So, as my last thing for today, which of your scores gives stronger evidence? Some. If I'm going to ask you a question, if I did both these simulations, do I have to simulate twice? Do I have to do them as two separate ones? Did I do two different scenarios? One test, but one test was how many questions? 10. But the other one was 100. Do I have to do two separate simulations actually? So can I ask one favor? Right? We still have 5 minutes. Can I have two people? One do the case where you did 10 questions. Show me your screenshot. Can I have another group do the 100 questions? I want to prove a point, and I want to close here because this is a good stopping point. I want to show you which one gives you evidence of stronger evidence that you're not guessing. The case where your score was 70 out of 100 or 7 out of 10. 70 out of 100 or 7 out of 10. Which one is stronger evidence against guessing? 70 out of 100. Getting a score like 70 out of 100 is more impressive than 7 out of 10, although numerically they're the same. So 70. Okay, so can I have two screenshots and then we'll go. Once we get that, I'll talk about get it with the p-value in. I'll tell you, I'll prove a point to you. Why we say this is stronger evidence, we can show you why. 70 of 100 is stronger evidence. All right. Can I just quickly see two screenshots and then we're out of here? All right. So just one for the case where you did 10 true or false, the other one for 100. You will see a difference. All right. We will revisit this next week, but I want to stop before you go with the two graphs because I wanted to be displayed. Can we have two groups do this? One group do the case where you have 10 and one do for 100. I mean, it can be the same person, but I just do two separate simulations. Shouldn't take you that long, right? And then just paste it here. Ooh. What happened?
It's a psychological
Okay, let me go back to this one.
bystander effect. Where you're like,
We're just waiting for the regular that does it. And study like what happens in or like someone's less likely to interview because someone thinks but if the amount of people.
Thank you so much. Here's one of them. This is a case where you did 100 questions. It's true or false, so it's 0.5. Very good. What's the p-value? Anyone? Do you see it? Can someone report the p-value? I'll type it here. Yes, p-value is 0. All right. You can see it there, the red 0. Can I have one last screenshot for the case where you did 10 questions and got 7 correct? All right. Thank you. See, is the p-value 0? What's the p-value here? Anyone? Do you see it? I see it. You've learned what the p-value is. It's a number, of course. But which one? Does anyone know? This is perfectly done, by the way. It's same score, 0.7. But they are not equal in a sense that one gives stronger evidence against the other. What's the p-value here? I can't finish the punchline until someone tells me the p-value here is 0.179. That's a very good place. Yeah. Now, who's bigger? Is 0 bigger or 0.179 is bigger? Of course, 0.179 is the bigger one. And what have I told you? If you look at our slides again, where are my slides? Oh, something happened. Okay. But anyway, the point is, if you look at my graduated scale, see? Okay, come on. Okay. See? If you go to a p-value more than 0.1, this was a 0.179 or something like that. So it goes into no more evidence. Getting a score like 7 out of 10 on a true-false test is not much evidence that you're not guessing. It's not very special, but 70 out of 100 is pretty hard to get if it's okay. So have a good weekend. And make sure you do your homework as soon as you can. Okay, the homework is even before all these things. All right, so I'll see you all next week. All right.